For least squares regression line, we're going to start introducing the calculator into this. The least squared regression line is essentially the calculator's version of the line of best fit. So we can all draw different lines of best fit, but the calculator is going to come back and tell us what the actual line of best fit is. So the following table shows the data for one season of the El Toro professional basketball team. And if you guys recognize the Chicago Bulls here, it's probably not surprising. El Toro team member Antonio Kusic was inadvertently left off the list. Antonio Kusic played for 2,103 minutes. We would like to predict how many points he scored during the season. So that's obviously Tony Kukoc, Michael Jordan, Scottie Pippen, Ron Harper, Luke Longley, Bill Kerr, or Steve Kerr, actually, the Warriors coach, Dennis Rodman, Bill Wennington, or whatever. Anyways, these are the Chicago Bulls of the... they just had a documentary on ESPN. I can't remember what it's called. Anyway, long story short, we are supposed to graph this data, and I'm going to go ahead and use this E-tool that they tell us to, and draw a line of best fit, and then use it to write the equation that models a relationship. So I'm going to go here, and they have this data for us, and what they do is they let us just sort of move these points around so that we can put this point where we think it makes the most sense at. And you can see there's Jordan way up there, so we don't want to forget about him. So the question is, where do we draw this line? Do we draw it to kind of hit the most guys, or kind of go through? So you can draw it wherever you want. I apparently am going to draw it about right here. Jordan's so far up there, I want to undo some of these guys down here. Maybe more like that. Something like that. Anyways, it's kind of up to you. So I have that. Now what I need to do is I need to write my equation for this line. So I'm looking for some lattice points. So I'm going to have to go over into here to come up and do the math on that. So my lattice points for this will be, even if they're off the scale, it doesn't matter. There's one right there, 900, 400. So I'm kind of jotting these down so I can get my equation. So 900, 400 is that one right there. And I will look for one. Oh, there's one right there. On the right side, 3,000 and 1,500. So 3,000 and 1,500. So I'm going to go back over here, and I am going to write my equation. By the way, you can see I do have a y-intercept right here. My y-intercept is negative 72, so I'm just going to steal that. And I will go in here, and I will give myself a little bit of room, and I will come up with my equation. If you remember, I had the points of 900, 400, and the points of 3,000 and 1,500. So my slope is my change in y over my change in x. It went up 1,100, and it went over 2,100. So I will divide 1,100 by 2,100, or just 11 by 21 if I lop those zeros off. And I get 0.524. So it's about 0.524. And if you'll remember, my y-intercept ended up being 0, negative 72. So what does this mean in context? Well, in context, again, x was minutes played, and y was points scored. So this means I would expect to score 0.524 points for every 1x, for every 1 minute played. So this is what my slope means. And my y-intercept here means that if I played 0 minutes, I would score negative 72 points, which of course doesn't make sense. You would score 0 points, not negative 72. But this is what my equation says. Now, if I go back over here, you'll remember Tony Kukoc was the one that we were supposed to predict for, or Antonio Kusic, whatever. He played 2,103 minutes. So if I go to my graph, you can see 2,103 puts me, what, about 1,020 points roughly. So the graph says about 1,020 points. That's my graph prediction. But I'll use my equation. So 2,103 times 0.24524, I'm sorry, minus 72, 1,030. So pretty good. So we'll say 1,030 points. So Kukoc, or Kusoc as it were, we would predict scores 1,030 points. So that's that prediction as we go through. What data point is an outlier? Obviously Jordan. And what data point does that represent, and what is his residual? Well, Jordan was way up here, right? Jordan was way up here, and his residual ended up being, I don't know, 30, 90, 24, 91. So I'm going to just go over here, 30, 40. I'm going to have to go back and write that again, unfortunately. So we have Kukoc's prediction. I do want the equation of the line, actually. So I'll say y equals 0.524x minus 72. All right, then I will give myself a little bit of room to figure out what's going on with Jordan. So Jordan's data point was actually 30, 90, 24, 91. So 30, 90, 24, 91. 30, 90. So this is his actual. Well, let's see what our prediction says. Our prediction says 0.524 times, we're going to plug in his x, he played 30, 90 minutes, minus 72. Our prediction is 1547. So our actual minus our predicted will give us the residual. And we can see Jordan's residual is 2491 minus 1547. So a 944 residual. So Jordan had a residual of 944. It says, would a player be more proud of a negative or positive residual? Well, probably a positive residual, right? A positive residual only means that they scored more points than we predicted. So Jordan's probably happy about the fact that he scored 944 more points than we predicted. Here's his actual, here's prediction. Again, it's above, so it's positive. Whoever this guy is had a big negative residual, right? All right, so continuing along. Predict how many points for Kukoc. We already did. It was like 2,103. No, it wasn't. He played 21 in 3 minutes. I don't remember what his prediction was, but it's earlier in the video. It says different people will come up with different models for the relationship between total points scored. Well, maybe it's 1,030. That sounds familiar. 1,030 points is our prediction, I think. So different people will come up with different models for the relationship between total points scored and minutes played in the previous problem. They will also have different estimates for the number of points scored by Kukoc. And that makes sense, right? Like your line might have been different than my line. So maybe your line was flatter, or maybe it was steeper. Maybe it had a y-intercept up here, or maybe it had a y-intercept down here. It just depends. Everyone's is going to be different. So what do we think when deciding where to fit the line of best fits? What makes one line better than the other? How can we numerically describe how close the prediction line is? Right, so the argument is going to be, well, the line I drew is better than the line you drew, which isn't a very compelling argument. We need math to sort of settle this argument for us. So it says, sometimes there's several different lines of best fit that can be drawn with the same sum of absolute values of the residuals. So I think a good argument would be like, look, let's just add up the residuals and see who has the smallest residuals, and that'll be the winner. However, that isn't exactly how we're going to do this. What we're going to do, and I need to pause this video to kind of show you. Okay, so what we're actually going to do is we're going to do more than that. We're not just going to get the residuals. And remember, the residuals go straight up and down to the line of best fit. But what we're actually going to do is we're going to square those residuals. So they're going to turn into squares. And you can see the smaller the residual, looks terrible. The smaller the residual, the smaller the square is going to be, right? This square is going to be tiny, whereas this square is gigantic. So that's what we're going to do mathematically. We're going to square these things, and then think about it, it's called the least squares regression line. The least squares regression line. So when we look at these squares, whichever ones have the smallest squares will be our winner. It will have the least squares regression line. So that's how we're going to determine the winner of this. And it's kind of a pain to do, so I went ahead and I'm going to use a spreadsheet document to do this. So again, our equation here, I think I've lost our equation. Shoot, give me a second. Got our equation here, y equals 0.542x minus 72. So again, what I'm going to do, I don't care who the players are, quite frankly, and I just check to make sure I have the right numbers here, but we're going to go ahead and we are going to figure out what our prediction is. So our prediction would be, if we take this equation, we're going to take whatever goes in here as our x, right? And we're going to multiply it by 0.524. And then we're going to subtract 72 from it. So our prediction for this guy was 1547. And then we'll just drag that down and it does all the math for me, which is pretty neat. So this is going to be all of my predictions. Now what I'm going to do is I'm going to compare my predictions from my actuals, right? So I'm going to get my residual. And if you remember, your residual is nothing more than your actual score, which these are the actual scores, minus your predicted scores. So here's all my residuals, right? And this is obviously doing it for me. But what we're going to do is we're going to square our residuals. So I'm just going to take this number here and I'm going to multiply it by itself. And if I copy that down, it will do that. Again, you can see this one is just saying G9 times G9. It's just multiplying this number by itself. But the interesting thing is you can see all the residuals some of the residuals are negative, but when we square them, they all turn positive. And now we'll just add this up. What does this column add up to? And it adds up to 1,597,850. So what you would do, and this is very time consuming, you would take your line of best fit. Oh, actually, it's very easy on a spreadsheet, right? But not so easy to do by hand. You would take your equation, you would plug in your x to get your predictions. Then you would take your actual minus prediction and get your residuals. You can see this one I predicted more than the actual, so it's negative. This one is I predicted way more points than the actual, so it's very negative. Then I'm going to square these residuals. Again, it's the least squared residual line. So we're going to square the residuals and we're going to add it up, and whoever gets the smallest number here would be the winner. Again, we don't have two lines to compare to, but if we did, one of these would have a different number, and whichever one had the smaller squares would be the winner. So that is Chapter 414, Part 1.